Hey everybody, I'm Robert Miller. I'm a steward and I lead product at Flashbots, a research and development organization focused on MEV. I'm going to be talking to you today about Rollup Boost, which is the next stage for rollup development. So in order to give you some context on this, we're going to start with the beginning of rollups, and in particular, the in particular, the rollup-centric roadmap. 4 years ago, Vitalik wrote this blog post. It really consolidated a lot of thinking in the Ethereum community at the time and sort of set out a technical and a product strategy for Ethereum to scale and address its high gas fees with the rollup-centric roadmap. And at the time, there were kind of two goals that the rollup-centric roadmap set out. The first was to scale Ethereum. We need to increase its transactions per second, make it a lot cheaper to do things on Ethereum. The second was to increase innovation. So we're going to review these goals and see how we are doing against them. If you look at what the, where do I put my clicker? This is a little finicky to move the slides, so sorry about that. If we look at rollup.wtf in the bottom right, or L2beat, we can see that we have unequivocally scaled Ethereum. So we have 25x'd the transactions per second on the chain. And in an even better measure, looking at the compute that Ethereum and its rollups processes, we have 65x'd in 4 years. So that is over doubling every single year since the rollup-centric roadmap has been executed. You now get sub-cent transactions across all of the major rollups. And so I think it's very clear that the rollup-centric roadmap has successfully scaled Ethereum, and we've sort of executed on that strategy. But how are we doing with the second goal on innovating in rollups? And there's a couple ways to cut this, 3 in particular. One is innovations that have started on L2 and made its way back to L1. Because one of the original ideas of the rollup-centric roadmap was we want to do all this stuff on L1, and we can use L2s as a test bed for these proposals before we implement them on mainnet. Because the stakes are lower there, because we can move faster there, it'll give us more data, and we can try many, many different things in parallel and then decide what we want to include on L1. One of the other forms of innovation feedback cycles is from L1 to L2. And the final is sort of innovation on L2s that doesn't make sense to do on L1, but allows people to pursue novel trade-offs and novel blockchain architecture. So how are we doing on this? And I think if you look, basically everything we've innovated on the L1 has made its way to an L2. So in the OP code base, they are very close to the standardized Geth client code base. We have blobs on the OP stack now. All the new precompiles on L1, all L2s sort of benefit from client development like Geth and Reth. So every innovation on L1 essentially has made its way to L2. But if you look at the other direction from L2 to L1, I actually could not come up with a single thing that L2 has innovated on that has made its way back into the Ethereum base layer. And so this feedback loop sort of seems broken here, where the L1 is pushing a lot of innovations and making its way to L2, but nothing has really made its way from L2 back to L1. And we do see a couple chains that are innovating on L2s and pursuing strategies that would not be possible at the L1. So Mega ETH is taking kind of a really opinionated stance on performance. It's trying to push the EVM to the absolute limit. It's taking a really hardcore stance, trying to be a proud centralized server constrained by a decentralized network. And that's a really opinionated take that the L1 just couldn't do, which is really cool. The Eclipse folks have the Solana virtual machine on top of Ethereum settling back as a rollup. And again, that's nothing the L1 could do. So those are two good examples of L2 innovations. And then we have folks like the Unichain, who Flashbots is supporting, we're developing with, that has sub-second block times, constrained by a trusted execution environment. Again, L1 couldn't do it. And the good folks at WorldCoin and with the World Chain that are trying to prioritize human transactions over bot transactions. And these are great examples of L2 innovation, but if you actually look where economic activity is, the overwhelming number of rollups are kind of working off of standard EVM forks, and they're not kind of innovating in the way that we had originally expected a lot of innovation happening in the rollup-centric roadmap. So what do we do about this? What Flashbots' answer to this is Rollup Boost. So it is our platform for next generation rollup features. And that means pushing rollups and their boundaries on performance, decentralization, and programmability, and allowing any rollup to easily adopt these next generation features to increase the innovation within rollups and help realize that rollup-centric roadmap. And how does this work? Before I get to how it works, I should mention we've co-developed this with OP Labs and Uniswap Labs. Rollup Boost is first going to go live on Unichain, and I learned that it is being experimented in a proof of concept by some other folks at the moment. So maybe going live there in the first or second quarter of the next year or two. So how does Rollup Boost work, and what is it? Rollup Boost is this really lightweight sidecar that the sequencer can run that sits between their OP node and OP Geth. It is something that you can run with no modifications to your sequencer, which is really cool. So you don't need to run any forks. You can know that this is sort of the canonical sequencer code run by or published by the OP team. And in turn, by running this, it allows you to enable these Rollup Boost extensions that give you next generation performance decentralization features. And why are we doing this? Again, just to hit the message home, because we want rollups to reach their true potential. We want to enable the next generation of innovation with rollups. What does that mean? What are our initial kind of extensions and how are we doing this? Flash blocks is our first extension. So this is 250 millisecond block times, which is a really cool feature for OP stack chains because the lowest you can go on OP stack at the moment, which is different from our good friends at Arbitrum, is 1 second. And many of those chains are actually limited at 2 seconds because they need to have a slower block time than their L3s. And L3s are 250 milliseconds or 1 second normally. So a lot of rollups right now cannot go below 2 seconds or even 1 second if you're OP stack. And the way that we are able to innovate on top of this, if my clicker would move forward, is by having these sub-blocks within our 1 second block. So Unichain, as an example, has a 1 second block time. And what Flashblocks does is it streams the state of that block as it is being built every 250 milliseconds. So every 250 milliseconds, the sequencer says, here is the state of the block. We break these up into 4 flash blocks. And that means that users get feedback on their transactions. They see how their transaction is executed in 250 milliseconds instead of 1 second or 2 seconds. And that's essentially instantaneous confirmation for a user, since your reaction time is about 200 milliseconds. And then what is really cool about this, in addition, is that we are using a trusted execution environment to give this guarantees of integrity. Because a trusted execution environment, you can verify what code is running inside of it, and you can know that once the TEE tells you this is the transactions that I've executed, it's not going to go back on that promise. So you have a guarantee of integrity on it. And the second thing is that the sequencer actually, even the party that is operating it, can't see transactions while it is producing those blocks. And so you get end-to-end privacy, which helps with censorship resistance as well. What I think is really interesting about this architecture is also that we're layering different types of finality. So at the sub-second, 250 millisecond timeline for flash blocks, you have a TE that is giving you a promise that this is how transactions will be executed. And for some people, that's going to be enough. You're willing to sort of accept what the TE has said. And then at the 1 second timeline, you have cryptoeconomic security from Unichain, which has a validator set that is then giving you a further level of finality if you aren't willing to accept the TE finality. And then, for the most hardcore users, they can wait for the Ethereum chain itself after that. And so I think it's kind of cool that you're layering these different types of finality and allowing people to sort of choose where they feel comfortable relying on the promises of a sequencer. The next feature that we're really excited about with Flashblocks is that it does not have reverts. So if your transaction reverts, the sequencer will not include it. And we think this is really cool because that means that users don't have to pay for failed actions on the chain, which is a lot closer to a Web 2 experience. Like, you don't pay money if you enter the wrong password and signing on to your email, as an example. Why should you pay money for a failed transaction? We're able to do this because as Flashbots, we run an L1 block builder that has had revert protection for a really long time, so we've gotten really good at managing spam protection. I won't get into all the details, but we're excited about this for, one, the UX benefits to users who now don't have to pay for failed actions, but also because it will actually end up giving more revenue to the sequencer. So there's a paper by Dan Robinson and a bunch of the Paradigm folks that showed that by having revert protection, you can actually induce more types of economic activity that are going to generate more revenue than you would make from the failed transactions, fees from failed transactions. And the final thing is that it actually will free up a lot of gas that right now is being used by MEV searchers who are trying to probabilistically find MEV on chain. So sort of the tripart of better UX, more gas, and more revenue, we think makes this a really cool feature. The final part about this is that the integration for a wallet is super simple too. So there's no new standards, no new JSON RPCs. The same JSON RPCs that you have right now, we're just using the pending tag in order to get the flash block. So very easy, and interoperable as well, so we don't lock anybody into one wallet. This is a feature that is inspired by Solana and Celestia. They stream the state of their chain as blocks are produced. And we are going to take this to the next step. Instead of just doing sub-second block times that are streamed, we're going to actually change the architecture of the full node to be continuously executing and verifying state as the flash blocks are emitted, which should improve the overall throughput of the system because you're continuously verifying instead of only doing that every second or 2 seconds. I am running up in time here, so I'll try to get through this more quickly. The second extension that we're really excited about is verifiable priority ordering. And in short, that's interesting, again, because of a paper that Dan Robinson put out called Priority is All You Need. This allows applications to internalize priority fees and MEV. You need priority fee ordering, which is not something possible on L1 because you can't guarantee that a block builder or a validator even is going to order your transactions by priority fee. But it's possible in the context of L2, which is slightly more centralized. And we think it's really cool because it opens a new avenue for applications to monetize, one, as well as to make things like LPing more sustainable or return MEV to users. And we guarantee the ordering by ATE as sort of a further integrity guarantee on top of this, which is really necessary because censorship is an issue with priority fee ordering. So what are we doing after that? I only have a minute left, so I'll race through this. We are going to implement TE validity proofs next, which we're really excited about because then we can get closer to having multiple different proof systems that we have confidence in that can then take rollups from stage 0 to stage 1, where a couple of us are at, and from stage 1 to stage 2, where there isn't a multi-sig in the hot path of rollup proving. We're doing this with the Autonoma team, a couple of whom are here, which we're really excited about. And it's also interesting for L3s because it should be ultra cheap and ultra fast for L3s. Probably more cheap than fraud proofs and certainly more so than ZKPs. So what are some other things that we're excited about? My slides are getting cut off here, but we're excited about doing some stuff that we think might make its way to the L1 eventually. That could be really powerful features for L2 as well. So that's stuff like a parallel EVM where execution is parallelized. We see chains like Monad innovating on that. Isolated and better fee markets. We could charge by piece of state so that when an NFT mint congests the chain, that means that people who are trading on Uniswap pools don't have to pay higher fees. We can isolate and charge per instance of state and lead to a better user experience like Solana does. Multi-concurrent proposer is a really hot proposal for L1. We should just implement that on a roll-up and test out with it, see how it goes to give more information as well. Fossil is censorship resistance. I see. I'm wrapping up. Fossil is censorship resistance. It's a gadget on L1 that we're interested in. We should just implement it on a rollup. Co-processing, interoperating with Web 2 for the next generation of apps, and adding multi-VM rollups where we don't have it right now. So these are a bunch of things that we're excited about. We're looking for design partners to build it on top of Rollup Boost to help us keep on innovating with rollups, and hopefully a bunch of these things start on L2s and make their way back on L1. So thanks everybody for listening. I'm Bert C. Miller. You can find me on Twitter or Telegram or here if you're interested in talking. Cheers. Thank you.